this, they can hear this. So somebody asked me about dialogue days. So here's what I would say. I'm not giving any extra credit, or I'm not expecting you to go to those. We're still going to have class. There isn't going to be a section in this room. All of our class is scheduled. So we'll be in here just like usual on Wednesday. Now, I would highly suggest looking at those. I don't know what other professors are expecting of you, but if you're in the business college, I would highly suggest looking at that list. If you can't find it, Google search Dialogue Days Ball State 2022, and it's one of the first links. I would try to go to at least a couple of those sessions that seem not only of interest to you, but of interest to you in respect to your career or what you kind of hope your career to be, or some jobs that you might think you find interesting, right? Because the real value of those dialogue days, look, what they're going to talk about is great. It could be very, very interesting. But the real value of them is all these people who are speaking, the vast majority are alumni, right? So like we have a bunch of alumni from the ECON department come in and talk, and a lot of them work at companies, and they love to find students that they can connect with and provide opportunities to in terms of internships and potential first jobs. So I know this because I'm on the advisory board and I deal with a lot of these alumni who are coming back to dialogue days, right? So the real valuable thing is try to find those sessions that are of interest at much to you to affect your career, and then don't be shy. Go up afterwards, as awkward as it might be. Talk to the person presenting. They're here for a reason. They want to talk to students. They want to be here. And sometimes just an email exchange can lead to internship opportunities down the road. I've seen it happen with a couple of students. And so I would highly suggest that's how I feel about dialogue days if I were you. All right. Any questions for me before we get started today? Okay. So where did we leave off? Okay. So we left off talking about optimal quantities, right? And we said the optimal quantity was what? If I'm thinking about how should a firm choose their optimal quantity, it's going to be a quantity, what is true? Think about in terms of this graph. We've got this kind of check mark looking marginal cost, or maybe initially it's decreasing because of specialization, but then eventually, right, we start hiring more and more inefficient workers, resources, and we see this increase in marginal cost. We said average total cost. I can try to draw this a little bit off here. Average total cost will hit the marginal cost at a minimum point. Right? And we then said, what's the optimal quantity going to be? Well, we also have this equilibrium price that we were kind of starting out assuming we have this perfectly competitive market, and every company, every person has to take the price of that good as given. It's whatever that equilibrium price is on the market. And so the optimal quantity was going to be where what? You remember? Where what intersects?
The marginal cost in that average.
Close, right? So the profit maximizing quantity is actually going to be where marginal cost is equal to marginal revenue. The reason why, because the difference between marginal cost and marginal revenue is the additional profit I'm earning from selling every single unit, right? So as long as marginal revenue is above marginal cost, I'm making profit off that unit, so I'm increasing profits. After this point where marginal cost is equal to marginal revenue, now if I continue to produce more and costs are greater than my additional revenues, I'm just going to be decreasing my profits there. Now, the relationship between price and average cost was, we said, you can kind of think about this also like this, right? That we know the amount of profit that's going to be made for a company is how many units they're going to sell, right? And I guess we want to get, this is like the equilibrium quantity or the optimal quantity the firm is going to choose. So the number of units the firm sells times, on average, how much do they make per unit by selling this good?
Well, on average, the amount they make is the difference between price and average total cost, right? Price is the same for every single unit, so the additional revenue is always that price. The on average costs, sorry, these are negative signs. I do know it's small, so really, these are negative signs, right? So the difference between price and average total cost essentially tells us the sign of profit. Right? We said once we identify that equilibrium quantity, where is average total cost? Here's my equilibrium price. Here, if the price is above average total costs, I'll have positive profits. If it's ever below, we said profits would be negative. A little bit of a summary kind of where we were at. Okay? So we talked about when everything's profitable. You can kind of think about if total revenue is greater than total cost, we have positive profits, which was another way. I think I've showed you multiple times just how you can kind of break this out, right? And rewrite this. This is all that equation. It's just total revenue minus total cost rewritten a little bit. So we want to have total revenues be greater than total costs, or the way we know that total revenues will be greater than total cost is if our per unit revenue, our price, is greater than our average per unit cost, which is our average total cost. Okay. So that's kind of where we left off. I don't think we went over this, but we can kind of think about I set up everything last class like we were in the long run. I wasn't drawing an average variable cost curve. So in the long run, hopefully we have this idea of how we can identify positive, negative economic profits, right? It's the relationship between price and average total cost. But what if we add in some variable costs and some fixed costs so that we've got the short run, right? Fixed cost being non-zero means we're in the short run. There's things that we can't change. They're fixed. So in the short run, we're going to have a difference between our variable and our total cost. So if I'm looking here, it's not up in the chart. What would my fixed cost be here? Yeah, yeah, right. We know that total costs are just my total variable costs plus my total fixed costs, right? Well, here, if I look at that quantity of 1, total cost was 30, my total variable cost was 16. So I can almost think about this like a math equation where my total fixed cost is X. I'm trying to solve for X here. A little bit of algebra, I can kind of see, oh yeah, my total fixed cost, or if I want to think about this, X is going to be 14, right? Just the difference. And I actually could have done this at any quantity. The fixed costs should always be the same. So the difference between total and variable costs, always $14, right? 102 to 115, $14. 78 to 92, $14, so on and so forth. So with these total costs and variable costs, I could then come up with my average total and my average variable. How would I do that? I've got this column, like how did I produce these numbers? I took total costs and variable costs and did what? Yeah, to get averages, I just take the cost I'm interested in, maybe total cost, and I divide it by how many units am I producing. The idea of average total cost is how much on average does each unit cost me? Well, on average, if I'm producing 100 units, right, and it costs me $1 million, $1 million divided by 100 units. And if you think of total cost, it's divided by the number of units I'm producing. So here, right, kind of easy to see on this one because the numbers work out nice. I wanted my average variable cost. I divide this variable cost 30 by 3, my quantity of 3. Actually, well, no, I pointed right here, 10, right? So my average variable cost is 10. And if I wanted my average total cost down here, is 72 is my total cost divided by quantity, 72 divided by 5, gives me that 14.4. So all we're doing is dividing by the quantity that we're producing to get those averages. Okay? Any questions about reproducing those columns, or is that making sense so far? A lot of this is kind of review of things that we talked about last week, but I'm setting this up for something a little different. Okay? So in the short run, right, I've got my average total cost curve. I've got, whatever that equilibrium price is, which represents my marginal revenue. At this, given this cost structure, what would profits be here? So let's be careful, right? The optimal number of units would be what? Four, right? Because that's where marginal revenue hits marginal cost, or the same. At the quantity of 4, the price is 14. What's my average total cost? Well, at that quantity of 4, the point that I'm on my average total cost curve is also 14. So if my price and my average total cost are the same, my profits would be, just in case we this written, we'll take, I'll write it over here on this side of the board too. All right. We're thinking about this represents my profits. So here I start out with a scenario where I've got 0 profits. Right? I think I mentioned this last time. We're going to call this kind of our break-even point, right? Because if that price goes above $14, we're now going to intersect that marginal cost curve. I think it's on the next slide. So we can see. There we go. If that price goes up, so it goes up from $14 to $18, well, now where's my optimal quantity? Just intuitively, before we even get too lost in the graphs and stuff, if I can sell something for more, am I going to be more likely to sell more or less of it? More. So what happens with equilibrium quantity? Even if we just we still follow that marginal cost equals marginal revenue rule. Well, now marginal revenue equals marginal cost up here at a higher quantity of 5. And then at that quantity of 5, what's my level of profits given that price? Well, the price is 18. Where am I at in my average total cost curve? Right here. If I go over, plot it 14.4. So now I've got price of 18, average total cost of 14.4. My quantity is 5. I just plug those values in and I can compute my profits. Right. So I've got it here, right? Where is it? There we go. I'll take that quantity of 5 and I'm just multiplying it by the difference between price and average total cost. The difference between price and average total cost here was 360. So on average, I'm making 360 for every unit I sell. The equilibrium quantity was 5 units. 5 times 360 would give me my total profit there. Or I can plug everything in this equation. I'll have to break it down into parts, but this is another way of thinking about it. Kind of first figuring out the optimal number of units, what's the profit maximizing number of units I'm selling, and then on average, what's the profit I'm making per unit. And that's just the difference between price and average total cost. Yep.
So my question is, at that point, E is a little bit up there on the marginal cost. So how is it that amount if the marginal cost is up there? Does that make sense? So it's a
yeah. So this is why when we're calculating, this is a really good question actually. This is why when we're get rid of this at this point. So this is why we're looking at the relationship between price and the average total. Because remember, marginal cost tells me the additional cost from that last unit. So yeah, for the 5th unit, my marginal cost is high, but remember, for my 2nd unit, they're all the way down here. So yeah, I'm making way more money on the 2nd unit I sell than I am on the 5th unit, right? But if I can figure out on average how much I make each unit, well, then I just have to take the number of units I'm selling times that average amount I'm making. But you're right, that 5th unit, I'm increasing profits by way less than when I sold that 2nd unit. Is that help answer this question? So think about it as marginal cost is different for every single one of these lines. And so, yeah, marginal cost is this high for the 5th unit. For the 2nd unit, it's much lower. So that's why we don't look at like the difference in price and marginal cost. We look at the difference in price and the average cost. And get how that can be confusing though. Any other questions on this? We'll keep moving. So I think we're good there. So I had before that when the price was at the break-even point of $14, well, then when the price went up, profits also went up. It's kind of intuitive. Right? What happens if the price falls below this break-even point? No, not good, right? Because if the price goes below, let's see, I gotta go forward here a little bit. Now, where's my optimal quantity? Well, now, Mark, so let's say the price falls to $10. and this gets a little bit goofy. If you ever have this initial period of specialization, your marginal revenue curve might hit marginal cost in two different spots. Okay? However, you know that you're always going to go to the last quantity that your marginal cost curve intersects your marginal revenue curve at, because if you just stop here at one unit, well, marginal revenue is very marginal cost for the additional two, you'd be missing out on profit. So you can't have this kind of weird thing where if the price falls low enough, it's going to kind of hit this specialization area. Always kind of choose that quantity that's the furthest quantity where marginal cost equals marginal revenue, right? But it could have 2 points that intersects that.
So the very beginning of the marginal cost curve, does that mean that since it's above 14 and 10, does that mean that to produce the first unit,
You'd be hitting loss.
Yeah.
Yep. And then on the second and the third unit, you'd be adding the profits. All right. So if you stop at one, negative, right? But if I continue to produce, I can kind of add a little bit more to profit in some of those next two units. Yep. Now, in practice, and like when we're looking at the homework problems, we're almost always going to be operating with prices that are like somewhere above this initial point, right? And in practice, price is never going to fall below this point where we get into specialization. So I'll make it a little bit easy, but kind of more to point that out that it can, you have specialization hit at 2 points, you'll always take the higher of the two. And the reason why is because for these additional units, the difference between marginal revenue and marginal cost is positive, so you're adding to your profits. So we said this is bad, right? If the price falls, because now where's my optimal quantity? Well, marginal cost with marginal revenue at 3 units. That's where I would be maximizing profits. But the price now is way below my average total cost, right? So now if I figure out what my average total costs are, they're 14.67. That is significantly higher than my price. So on average, it's costing me more to produce every unit than what I'm making. So my profits are going to be negative. Once again, I just plug things in my profit equation. I'm selling 3 units, price is 10, average total cost is what, 14.67, right? It's going to be a matter of kind of plugging all those in my calculator, right? And I can break it up into steps. I can find the difference between price and average total cost, and then multiply by quantity. Or if I've got this equation, I can kind of plug everything into it. Questions here before we keep moving? And I think here this is an intuitive result too, that if the price goes lower, what happens if equilibrium quantity that firm produces went down? I went from 4 to 3. I'm keeping these numbers context. You think so? The other thing I want to point out here, and this is before you get to the discussion about shutdown prices. So let's assume that I've got kind of my market supply and my market demand. This is like, remember, market supply is adding up every producer's supply curve, market demand adding up every individual demand curve. So there's all these buyers, all these sellers. We arrive at this equilibrium point, right? And that equilibrium price is what firms will kind of use as their marginal revenue, right? That's what they have to sell the good for. So they determine their optimal quantities for. If something happens, there's more consumers, maybe for a normal good, income goes up, the price of a substitute good goes up, maybe we see this increase in our demand. Well, increase in demand is like this shift to the right, so these are things we've already talked about. Where's my new equilibrium price? A little bit higher. Now, once again, intuitively, with a higher price, what do you think is probably going to happen to the optimal quantity? If I can get more for selling the good, I'm probably going to sell more of it, right? Sure enough, at this higher equilibrium price, my new equilibrium quantity is going to be 5, right? So I'm going to sell a higher number of units. And if I were to put an average total cost curve on here, what's more likely than not is that we're going to see at these higher prices, it also increases my profits. Okay. Which is also another intuitive result. But here I just want to get at the idea that this marginal revenue curve, the equilibrium price, firms are taking it as given, but it's coming from somewhere. It's coming from the overall market demand supply. This is just the quantity of the firm itself. So if we wanted like market supply, take how much each firm is producing and multiply by the number of firms.
Any questions about the relationship between kind of the overall market supply and demand, and then kind of what we see kind of in terms of the optimal quantity for these products? I already went through this. I jumped the gun kind of last week, and already headed into the discussion today. But you can think about profits in two ways: total revenue minus total costs. Or we said, well, we know total revenue is price times quantity. We kind of this tricky thing where average total cost is total cost divided by Q. So if I multiply average total cost by Q, it's actually just my total cost, because like Q over Q is 1, multiplying by Q is 1. And then when I plug those two things in for total revenue and total cost, I can kind of distribute that quantity so that I can rewrite profits as the difference between price and average total cost times the quantity I'm selling. So I've already kind of went through this, but just to reiterate. Okay. So we're going to use this equation a lot, right? Hopefully over time, it's not too complicated an equation. When it comes to the exam, I'll write it down or write it on the board for you, but this is going to be our profit equation. So what becomes a little bit more interesting is that now that we can understand positive and negative economic profits, we get this weird scenario where some firms, and I think somebody asked this last class, if I'm earning negative profits, if I don't expect the price to change at all, what is that firm probably going to do? Get the hell out of that industry, right? Now, the difference is that that was in the long run. In the short run, we could actually have negative profits, but the optimal quantity might not be to choose a quantity of 0 or to shut down. You might still operate, and yeah, you'll have negative profits, but by staying open, you're minimizing your losses. Okay? So this is kind of a harder concept for people to grasp, but if I'm maximizing profits, and let's say I had something like this. What quantity do I want to produce? I'm trying to maximize profit. 3, right? That's where profits are highest. What was I trying to do there? I was figuring out where's the highest number for profits. But we get this kind of weird scenario where let's say, no matter what quantity I choose, so I'm always going to have whatever the market conditions are, whatever my cost structure is, profits are all negative at all these quantities. What quantity would I want to choose to produce that here? Well, I would still choose 3 because maximizing profits is choosing the highest number. I'm still trying to maximize profits. It's just when all the numbers are negative, the highest number is the lowest negative value. So minimizing losses, making that negative number as small as possible, is just another way of saying I'm still maximizing profits, right? It's just that now all profits are negative, right? And so generally we kind of maybe refer to this as minimizing losses, but it's really the same thing. So we may not want to choose a quantity of 0. We may actually choose a quantity because let's say I left off 0 here. Let's say 0 was, I don't know, -10. Right? It's plus. Probably not this. It's hard for me. Right? So 1, 0. Let's say this is no, we can't have these profits here. Let's say this is -10 or something like that. If I choose to shut down and produce nothing, I've got these fixed costs in the short run. So in the short run, if I just shut down, my profits will be -10. If I stay open, produce a higher quantity of 3, I'm still earning negative profits, but it's a lot higher than -10. I'm only at -3 now, right? So I've minimized my losses by staying open. And maybe I do this because I think that down the road, prices are going to go up, right? Maybe market conditions will be like, I'm a company right now, I might operate with some negative losses this year because I'm hoping things get better. So we might not always kind of want to exit the industry or just shut down in the short run, and because we might have these fixed costs, right? And so it may be staying open and allows us to kind of minimize our overall loss. So we're going to only shut down if the losses from staying open, right, are greater than the losses from shutting down, right? Because if by staying open, I'm just creating a larger negative value, and then I'm not going to stay open.
So we can think of a couple examples of this, like this is like actual application. So I'm not just like making, we're going through this for the sake of going through it. There are plenty of companies that operate at a negative profit or at a loss in the short run. Anything seasonal, right? So if you think about ski resorts, it's not like they shut down their business, declare bankruptcy every summer, right? They still are operating, right? And they might find different uses for the resort, or maybe certain months the demand isn't as high, but they know they can make up for it down the road when they expect prices to be higher. So they'll operate kind of in the short run with these losses. Any resort town, like you look at restaurants, I'm from Southwest Michigan, so like along Lake Michigan, there's all these tiny little towns. They're like 1,500, 2,000 people. There's like in a town of 2,000 people, I think in one city in specific, it's like New Buffalo, it's right in the lake. There's maybe 20 restaurants, right? For a town of 2,000 people. Why? Because in the summer, there's way more than 2,000 people in that town. Right? There's a lot of second homes, right? And so in the summer, these restaurants can operate at a pretty large positive economic profit, right? And they stay open during the winter, right? Even though they might be generating losses, it's better that they just completely shut down, right? At least they're selling to the locals, right? They're not just paying, the lease on the building that they're operating and not selling to anybody, right? So they're selling something, it's just not as good as their other ones. So we see this play out a lot. And we want to think about, well, when does it make sense? Because that same resort town, some restaurants will stay open all year round. Some of them decide to sell a quantity of zero in those winter months. They close down from like November to March, right? Because they must believe that staying open would actually incur greater losses than if they just produced zero and maybe just had to pay their fixed costs. So how do we determine when we should shut down? How are some of them figuring this out, right? So we talked about when price is below average total cost, we know that profits are going to be negative. And I don't think depends on how much time we have. I probably won't work through the mathematics. I might try to show you at the end. It's a little bit, I don't want to confuse anyone. But instead of looking at price and average total cost, that tells us the sign of profit, right? If it's positive or negative. We actually break this down. So I can rewrite my average total as my average fixed and my average variable, right? We've already talked about this. So I can kind of complicate my profit equation a little bit. If I then rearrange things, well, quantity times average fixed cost is just whatever the fixed cost was. So you'll notice if I produce a quantity of zero here, what would my profits be? Not close, because this quantity is only being multiplied by the difference between price and average variable. So if quantity is zero, my profits would actually be just negative whatever my fixed costs are, right? By shutting down, I still have to pay the rent on my building, the lease on my building. I still have to pay for whatever machinery I'm still like paying off over time, right? I have to make these payments, right? So if I produce at a quantity of zero, you kind of think about it as my profits are negative whatever my fixed costs are, right? But if I stay open, let's say I produce at a quantity of 10, right? I think about that profit equation, and I told you, okay, you're producing 10 units, and I'm going to tell you, whatever we're selling, price is $20, and the average variable cost is 15, and your fixed costs are, I don't know, 100. So maybe this was negative 100 here. Right? So shutting down, I'll have to pay my fixed costs, which were $100, so my profits will be negative 100. I'm not selling anything, so I have no revenues, right? At 10 units, well, the difference between the price and the average variable cost, right? So for every unit I was selling, here was my added kind of variable cost. Here was my added kind of revenue, whatever the price was here. So this amount is what? $50. I still have these huge fixed costs of 100. Well, at least now by operating and staying open, I can minimize my losses, right? If I completely shut down, I'm out $100. If I stay open and sell this good, at least I'm only down 50. Well, that's a better scenario, right? And I'm holding off maybe until for the summer months, right? And those other examples we were doing, right? Where I can actually maybe see the price of this good go up and I can earn positive profits. So because we can kind of rearrange this equation, what this allows to see that when are we going to be able to minimize losses, or when is it better to stay open as opposed to shutting down? Anytime this component here is positive. Well, when is this positive? Whenever price is greater than the average variable cost. There's a reason why we're breaking total cost down into variable and fixed, because in the short run, as long as price is above my average variable cost, or said differently, the difference between those two is positive, then I'm minimizing my losses by staying open, right? So I think I might have this on the slide, but just to kind of give you as a more general rule of thumb, make this a little bit easier. So anytime my price is greater than or equal to my average variable cost, this component will be positive. So it actually makes sense to stay open, right? Anytime that price falls below my average variable cost, then on average, I'm adding more costs than I am revenue, right? And so this would kind of be close, or I guess think about this as another way to say that, right? My shutdown kind of decision. I'll decide to shut down if the price ever falls that low. Okay. Questions on that? Kind of take a look at what this looks like graphically here. So, what does this look like visually, right, on the graph? So I've got my average total cost in a U shape, and I've got my average variable, which I know is always a little bit lower, right? The difference between those being my average fixed cost. Okay? Thing we talked about. I could then put in my marginal cost curve, right, to hit both of those at their minimum point. And then I can think about something like, okay, let's assume that the current price, the price I would need to kind of break even in terms of profits is going to be this minimum point in my average total cost, right? So we said if the price ever goes above 250, I'd be earning positive profits. If it ever falls below 250, negative. So now we'll think about, okay, we know that if the price is above 250, awesome. Profits are positive, and that's great. Anytime the price falls below 250, I've got a decision to make. Do I shut down, or can I minimize losses by staying open? So if we think about here, the next kind of like break even point, now it's not break even in terms of profits, right? But it's going to be the minimum point my average variable cost tells me, okay, if the price is ever above that, well now, back here, if price is above that lowest average variable cost, I know that that will be positive, and I'll actually be minimizing my losses. So if the price is ever in between $2 and $2.50 here, I know that I'm going to have a price that's above my average variable cost, right? And so I'll be able to kind of minimize losses. Now, if the price ever falls, so positive profits. Oh, I forgot one. I went through this one first. Here's where we'll stay open and minimize losses. But then if it ever falls below $2, well, that's where I know staying open, if the price is below average variable cost, if price is below average variable, then this is going to be negative, and I'm just adding more of a negative value of profits. So if price ever falls below average variable cost in that red category, I'm going to shut down. It's better to just produce nothing. So really, it's the relationship between price and average total cost that tells me the sign of profits, but it's the relationship with price to average variable cost that tells me whether or not I shut down.
If the firm's operating in that like yellow zone for a while, they eventually get shut down.
So in application, right? Yeah, it would be unsustainable over time. And then you're saying over the long run, right? If I continue to operate with negative profits, then yes, if eventually in the long run, I've changed everything I can. I've moved to a more cost-effective building. I've changed all this stuff, and I'm still operating at a negative profit. And yeah, I leave the industry, right? So which of these two areas would I expect profits to be negative in? What colors? It's red and yellow area, right? Profits are negative in both. It's just that in this yellow area, by staying open, I've minimized what those negative profits are, right? I've kind of minimized my losses. So this is just kind of some of those kind of thinking about the relationship between price average total, price and average variable. Okay. So I think I need a short run supply curve. I think where I go through here. Thinking about it. So I do want to go through some of these quicker questions. This is basically what I had before. The only thing I want to point out here is anything above that kind of shutdown decision price, right? I will see people supply something to the market. So anything below, companies just shut down, so there's nothing supplied to the market. So it's almost like at every price below $2 here, quantity would just be zero. Supply would be zero. So the only time I really have to worry about my supply curve is once that price gets above average variable. And then I'll see some companies actually produce and sell something on the market. So more generally, that's why when we're drawing out our supply curve, we never draw this initial kind of specialization area, because usually that shutdown decision price is going to be somewhere above that. And so we're just thinking about kind of our typical supply curve, right? I said supply represents marginal cost. The reason why I didn't start out at the beginning of the semester drawing supply as like this check mark is because any point below the average variable, we really just get zero, right? So it's almost like when we're thinking about the supply curve, I sometimes draw it like it's coming from that 0, 0 point. But when I was giving you equations, usually it was something like, I don't know. Here's my supply curve. I would have some intercept. Really what that intercept is telling me is that if the price ever falls below $10, I'm getting zero production. So it's like my y-intercept actually represented this kind of minimum average variable cost. Because if the price ever falls below the minimum of that average variable cost, our quantity just goes to that zero, right? So that intercept is kind of telling my minimum average. And to line up with the slides here, I guess I shouldn't have chosen. I chose 10 because of the equation. In terms of matching up with the slides, that would be starting at that $2. All right. Some questions that I started trying to work through a few of these. Okay. So, seeing some of the types of questions we could answer if we had our cost structure drawn out for us. Okay? So once again, if I think about these different curves, and I was trying to label them, what's my red curve? Average fixed cost, right? As I produce more units, it just spread out across more units, so it's always going down. It's a little bit goofy, I think, which is the way I plotted it. So this blue curve is going to be marginal cost. Generally, I was drawing here, but I had to have a point in the y-axis there. But you can think about the reason why it's marginal cost is it's intersecting these other two curves. It looks like at their minimum point. So those other two curves must be what? This blue curve is marginal cost. The green curve would be average variable, and the black curve would be average cost. So we got that. Gonna figure it out. So what would the break-even price be here, right? So the break-even price refers to the price at which, if the price goes above it, profits are positive. If the price falls below it, profits are negative. I'm trying to eyeball that. So where am I going to look at for the break-even price? What curve? The black curve, right? Or my average total cost curve. The minimum point on that average total cost curve, we said, well, that was the break-even price. So this point right here, so if I go over right there, well, it's kind of hard to see either jumps, right? This is 250, 75, 300. So this would be at a price of 275. Everybody following kind of how I come up with that break-even price? I didn't open this question up. Sometimes I'll have good questions. These are just good ones to always be able to go back to and know you can solve. So even though I don't use them for an iClicker, I label them like that in the slides so that we get closer to the exams, you can kind of go back and make sure you know how to solve those. Okay? Yeah.
So you're not getting it from the red line?
No, right? This red line right? This represents my average fixed cost, right? So the break-even point is the minimum point on that average total cost curve, which we said is just kind of black U-shape for those other. Okay. So I just identified the break-even point, right? If I wanted to figure out the price, sorry, but if you wanted to break down the price, we're going to decide to shut down. Notice I don't have the additional part of the marginal cost curve here because I wanted to make a point, right? If I can see that this minimum point of my average variable cost curve is right here, then that price, if the price ever goes above that minimum point, I know that price is above average variable, so I said there I was minimizing losses. If the price ever falls below the minimum of my average variable cost, we said the quantity supplied was just 0 or firm shutdown. So my shutdown price would be this minimum point on my average variable cost curve, that 175. Okay. We're okay with sort of identifying those points. Are there any questions on that before we keep moving? Okay. So this one, I may actually give you guys a little bit of time to work on. Okay. So I just identified the two break-even prices for you. And this is where maybe having it pulled up on your computer might help a little bit, kind of see what some of these grid lines are. Think about this as these black grid lines all represent 50s. The light grays would be jumps of 25. So talk to the people around you. I actually want to see kind of how we're understanding this. But if I wanted the break-even quantity, so we identified already, if we were paying attention, to the break-even price. We said that break-even price is at 275. If I wanted the break-even quantity, all right, or the quantity I would need to sell in order to kind of then see positive profits, what quantity would that be? Talk to the people around you. I'll give you a little bit of time working this, and we'll kind of come together. Okay.
B.
I see that. I see that completely. I just don't know that.
That's where the black one.
So remember, we're thinking about the break-even price and the break-even quantity that separates positive and negative profits, not the shutdown price and quantity.
Yes. That's the black one. Break even with the minimum of the so it should be good.
Wait,
This is the black one.
I'm not trying to trick you.
This is the minimum of the average for the cost.
Yeah. So it is
even?
Okay.
The break even for the price is 75.
All right. If you haven't gotten an answer in, take your best guess here. All right. I'm going to close it out. So we got 33 of us here today. All right. 34. All right. I'm going to close it out. So let's see. All right. So we got a little bit of spread out answers here. So I said the break-even price is what? The minimum point and then average for the cost curve or 275. The corresponding quantity would be 300. Right? All I'm doing is looking for that price quantity combination. It's at that minimum point of my average total cost. So instead, if I ask you for, and then we've got a couple minutes left here, so let's instead. Another one we can work through. I won't make it kind of work through this. We'll walk through it together, but I want to kind of show you what you could be asked on an exam of something up here. If the price is $4.50, right? What's my equilibrium quantity going to be? First of all, we said the break-even price was $2.75, so I know for sure that profits are going to be what? Positive, right? That price of $4.50 is well above that break-even price, right? To calculate profits here, I need three things. First, what's the optimal quantity for this firm? that should be the quantity where what is equal to what?
Marginal revenue is equal to marginal cost.
Marginal revenue is equal to marginal cost. Well, what's my marginal revenue? Market price. So 450, I would have kind of this horizontal line. Looks like it intersects my marginal cost right here. So I'm gonna figure this out now. 450, follow this down to a quantity of 350. So I've got that quantity of 350. I've got my price of 450. The only other thing I need to know is at that quantity of 350, what's my average total cost? At that quantity of 350, my average total cost would be right here or 300, right? So I then plug in 300 here, 150 times 350. Top of my head, I'm guessing is right? Oh no. Is it A? If I do that in math, 150 times 350. Okay. That's kind of the steps that I would work through. I have my profit equation. I identify the optimal quantity. I know the price, whatever the market price is, and then I look at the optimal quantity, what's my average total, plug everything in, and I find profit. Okay. We'll kind of pick up on this next class, talk about what the long run looks like a little bit more, and then kind of shift into monopolies. Okay. All right. I'll see you guys on Wednesday.